Hello everyone! In this lesson we're going to be introducing ourselves to the basics of Python programming language, as well as writing our first ever Python program. If you followed all the prerequisites from previous lesson, you should have Python already installed in your machine, and to check whether the installation was successful and what version you currently have, you can just go to terminal and type Python or Python 3 depending on what version you have installed, and -- version. Skipped an S here. And it will return the current version of Python you are running. Now, how do we actually run Python code? Well, the easiest and the quickest way is to initiate a Python simulator inside our terminal, and we do that just by running Python 3 without any arguments. And it will open our Python simulator, and everything we write here will run as if it's Python code. So for example, let's do the most basic Python line, which is print hello, and it will execute hello. We could also do some basic mathematics. 2 plus 3 will return as 5, 2 minus 3 will return minus 1. So we can see our Python is working just fine. But in here, all the information you put in is only saved in this session. So if you wanted your code to persist once you exit this session, you would actually write it in a separate file and save it. So let's do it now. In order to exit this session, you just type exit and 2 brackets, which will return you to the terminal. In order to create a Python file, you can use any text editor you want, but I'm going to use Atom. And the way we do that is by typing Atom and the name of the file we want to create. So I'm going to call my file playground.py. .py is the extension of the file, meaning that the contents of this file is going to be interpreted by the computer as Python code. And I'm going to click return, click enter. As you can see, I already have something written in my playground.py file, but if you were creating a new file, it would be just empty as such. So now that we created our playground.py, we can write our Python code here. In today's lesson, as you can see, we're going to be exploring the basics of printing and outputting stuff in Python, the basics of mathematics, how do we store information in Python, such information such as numbers, strings, and lists. And we will also, closer to the end, explore how do we take input from the user. So, I know it's a bit daunting and a bit intimidating at the start when you don't really know anything about the language to expect, and people expect you to write something in it, but there's also a flip side to that, meaning that you can write pretty much anything you want. Anything your brain can imagine, you can write in the programming language. Almost anything. So let's start with some basic commands you can use in Python that will help you make your dreams come true. So printing. As you already saw in my terminal right here, the way you print stuff in Python is using a print command, a print function. And you give them some arguments, aka the text you want to print. If you have been programming before, have seen anything relating to programming before, you know that print hello world is the first print statement you will do when you're learning any programming language. So we have written that, and now it is saved in our playground.py file. So how do we run it? Well, we go to our terminal and we type Python 3 and the name of our file, playground. Since our file already exists, I don't need to type the full name. I can just start typing the name, for example, play, and hit tab, and the terminal will autocomplete the name for me. That saves you a bit of time, and obviously if you're working a lot in programming, that will be helpful. And just click enter. And as we can see, our program executed exactly as we expected. It printed hello world. That's what we told it to do. Now, let's talk about mathematics. Math in Python is extremely easy. It does pretty much exactly what you would want it to do. There's additions, there's subtractions, there's multiplication, and there's division. So let's check out how it works. If I just type 2 plus 3 here and try to run the code, nothing will happen, because it added 2 plus 3, but I didn't print it to the terminal, so I would actually need to add the print function which we learned in the previous section, save my file and run it again. And as a cool trick, if you want to run the command again, which you run previously, you don't need to retype it from start. You can just click the up arrow key and it will bring up the previous command you ran. And if I click enter, now we can see it printed 5, because that's exactly what we asked it to print. We asked it to print 2 plus 3. If you asked it to print 2 minus 3, save the file, run it again, minus 1. Exactly what we'd expect. Let's try multiplication. 2 times 3 is indeed 6. And division. 2 divided by 3 is 2/3 actually, but since we are dealing with computers, they don't understand real numbers. So it rounds it up to the nearest 20th decimal, 0.66666, obviously being a very close estimate of an actual answer. So we can see math works exactly as we'd expect it to. Now, it's usually not very helpful for us to just do some basic mathematics. We actually want to take those numbers from somewhere and store them somewhere once we've completed our computation, right? So how do we store numbers? Well, we store numbers in variables. One of the ways of storing information, storing data in Python is through variables. And in order to store some data in there, first we need to declare a variable. So for example, let's declare a variable named result. And we will save 2 plus 4 in there. And now we can reference this information, this data saved inside this variable, just by referencing its name. So if we want to print result, we will run our code again, and it will print 6. That's exactly what we have stored in our result variable. You can notice sometimes I'm putting semicolons in the end of my lines of code. That's because in Python 2 that was required, but in Python 3 that's no longer required. But it is still an option you can do, so it's up to you whether you do it or not. And we can store, again, pretty much anything in here. We can do 2 plus 4 divided by 2. Can you guess what our terminal is going to print out when I run it? And printed out 4.0. That's because division happened first. 4 divided by 2 is indeed 2, and 2 plus 2 is 4. And that will work the same with multiplication and any other mathematical operation. 2 plus 4 over 2 times 5, so 4 over 2 is 2, times 5, 10, 10 plus 2 is 12. So indeed it works as we expected. But what if we wanted to store a different type of data? For example, text. Well, we could store it in exactly the same way, in a variable. You could create a variable, let's say text, let's name it text, and we would set it equals to some piece of text. For example, hello, how are you? And we could reference it in exactly the same way as we did with numbers. We can reference it in a print function, print text. And now if we run our code, it will print hello, how are you? Because we referenced a text variable, it found a variable, and it found the information inside it. There's a representation of how the text is actually stored inside memory, but for the time being it's not too important. This is a small peek into the future of your programming career. Text is stored in an array, and each part of the text, each word or each letter or each space or each symbol is actually stored in its own little space, its own little box. And there is an interesting or rather unusual way of referencing it if you're not used to programming. But we can get to that later. Now let's explore storing the third type of data, which is lists. So we know how to store numbers, we know how to store text, but what if we wanted to store multiple pieces of data in the same place and reference it with one variable? Well, we can do that as well. Let's create a list named list. And lists are created with square brackets. And you can put items in there separated by commas. So now we have created a list and it has 3 items, 2, 3, and 4. And again, since it's a variable, we can reference it in functions like print function. If you print it, it will print our list, 2, 3, and 4. If we change one of the elements in our list, for example, to be hello, and run it again, it will print our list as follows. First element 2, second element hello, and third element 4. That's how we want to store, that's how we can store data in a list if we want to group multiple pieces of data in the same place. Now you may notice I'm going through it quite quickly with very little detail into how exactly does it work in the background behind the scenes. And this is because as a beginner programmer you don't really need to understand how does Python run your code. You just want to learn as many different options you can use with Python and start writing your code. And as you practice, you will automatically learn how is it actually carried out. Now let's quickly go through 2 more topics, which are input and commenting. I'll actually go through commenting first. You may notice that some of the code in this file is executed when I run the code. For example, this, and this. But some of the code is not executed. For example, these lines or these lines. That's because there are comments. So the way comments work in Python is you have one-line comments and multiple-line comments. One-line comments start with a hashtag, and what it tells Python compiler is to literally ignore this line. All this line does is it exists for the user to understand what's happening. The computer doesn't run this code. And the same with multiple-line code. It is done with 3 dashes before, 3 dashes behind, 3 dashes after, and everything in between is considered a comment. Computer will not execute it. Comments are extremely useful because they help you structure your code and they help other people who might read your code in the future understand what on earth are you doing, because code inevitably becomes more and more complicated as you solve more complicated problems. So that's with regards to commenting. A hashtag for a single line comment and as such for a multi-line comment. Now on to the last topic of today's lesson is input. How do we input data into our Python program? We know how to store it, we know how to retrieve it from storage, but how do we take input data from the user? Well, actually there is a very simple function for that. We already know a print function, so let's learn another one, why not? And the name, as you might have guessed it, is input. So if I run this line of code, it will write the following piece of text in our terminal, and it will wait for user input. So the program will not terminate until the user has entered some sort of input. So let's try it. I run it. Hello, please enter your name. And if I enter my name, the program will terminate. Now, right now I just inputted it, but I didn't do anything with the data. We can actually store the data we retrieve from the user in our memory, and one of the ways we can do that is to store it in a variable. So I created a variable named username, and I'm gonna store the input from the terminal in this variable. And to check that it was stored correctly, I will print it afterwards. Let's check if that works. Again, it asks for my name. Hello, please enter your name. My name is Nazar, and it printed Nazar because that's the name I input. You can notice there is a space here which got printed. That's because when I was answering an answer here, I added a space. So now you know quite a bit about Python. So where do you go from now? Well, the way I like to think about Python is in terms of building blocks. Each line of code is a small building block, like a piece of Lego actually. And as a programmer, your job is to think of building blocks that would combine together to create something massive like a castle or a plane. And it's your job as a programmer to be creative with these building blocks. You learn building blocks, and then you can, once you know all the basic building blocks, you can build pretty much anything. So we know all of them. Let's create something that's potentially more useful than just writing a bunch of numbers and asking me for my name. Let's write a program that might actually have some use cases in real world. So let's come up with a real life scenario of something a real program would like to do. For example, when you register on a website usually asks you for some information, for example, your name, your email, your phone number, and so on and so forth, in order to let you through a website. So let's create a program as such. Let's do it in a different Python file and create it as follows. I'll call it welcome.py. It's usually a good idea to name your files based on what they actually do, so that, again, when someone else reads them, they understand what's happening. You wouldn't call files that welcomes someone a random name like a bee or sofa, because that just makes no sense and makes your code very unreadable. So let's create welcome.py. It will open a new file in our atom. And let's write what an average website would usually want to do when they welcome you to their website. So they would want to input your name, right? They would also want to input your email. And maybe also your phone number. But right now they will just input it, right? They will not store it anywhere, and usually a website would want to store the name, email, and phone of their users in their database, right? So let's store it in a variable for the time being, since we don't know how to use a database. Name will be stored in a variable named name, variable named email for email, and variable named phone for phone. And to check that it is stored properly, let's actually print it out. Print name, print email, and print phone. Let's run our code. Python 3 welcome. Tab autocompletes my command. It asks for my name, Nazar, email, nazar@gmail.com. That's not actually my real email, don't try to send anything there. And my phone, +11 22 33 44 55 66, whatever. And we can see that it was stored perfectly in our variables, because it printed its information back to us. Now, that's not actually what would happen in a real case scenario, right? Because when you register, you don't get the website sending you information back to you, right? Usually what the website would do is take your information and say, oh, welcome to our website, please enjoy your stay. So let's do that. We will delete email and phone because it wouldn't use that. It will use your name. And let's do as such. You can see we haven't learned this yet, the addition of a text and a variable, but this is pretty self-explanatory. The print command will print the welcome plus the information inside the variable named name. And there's a general rule of thumb. Whenever you don't know how something works in a programming language, in Python or any other for that matter, the best way to learn is to try, and if it doesn't work, you will get an error which explains why it didn't work, and so on and so forth. So let's try to run it. It asks for our name, Nazar. Not gonna enter an email again. And it printed welcome Nazar. That's exactly what we told it to do. Obviously, this is a very simple example of what we might do in real world, and real programs are way bigger and way more complicated. But the biggest programs in the world are all made up of the smallest building blocks of variables, of inputs, of print statements, and so on and so forth. So as long as you learn how to think as a programmer, as long as you learn how to combine the smallest building blocks to build bigger and bigger and bigger objects, you can build, as I said, pretty much anything. That concludes this lesson. What I would like to tell you is You have learned quite a few techniques that you can use in Python, but to actually understand what they do is what you need to do is practice them. Try to print things that you wouldn't expect to print, like 2 plus 3 or 2 plus text or 2 plus a variable name. Try to input with a text or with a number or with a variable name. Experiment. So each of these building blocks, try to shuffle them in such a way that might break code. So that's exactly how good programmers think. They try to think in a way that will break code. And once you break it, you will look at the error code, which will appear in the terminal. Read it. Don't be scared of it. Error codes are there to help you figure out what's wrong and try to solve it. And that's the best way to learn. If you have any questions, you know how to reach me. And that concludes today's lesson. Thank you very much.